All right. So our next speaker is Sneha Talwalkar. Sneha is an incoming PhD student advised by Teakin Maharaj at the Faculty of Information at the University of Toronto. She holds a Master of Science in Cybersecurity from the Georgia Institute of Technology and a Bachelor of Engineering in Electronics and Telecommunication from Pune University. Her research interests are information security, AI audits, and governance. She has worked with leading companies such as IBM and Vodafone as an information security professional for a decade in domains such as data security and risk management, communications and network security, software security, access management, security ops, vulnerability assessment, and compliance and auditing.
Thanks for the introduction, Sarah. So hi, everyone. So my talk today will focus on comparing risk management for two different scenarios. One is a result of an uncontrolled network automation, and the other is a model mislearning. So my hope is that by the end of this talk, you will have some more interesting questions in your research toolkit. Okay. So I had questions about what is AI safety? How does that relate to cybersecurity when I started? And this book by Dr. Yampolsky, if you guys are interested in starting out, I do recommend this book because it answered my questions about how does cybersecurity principles and safety engineering principles relate with AI safety and security. Now, this is our first example. What you see in the center is a small internet service provider by the name DQE Communications, which is located in Pennsylvania. And in 2019, they decided to use a software for automizing the routes. So the software essentially gave them better routes to avoid local network congestion. And Verizon advertised those routes to the internet. Now, Verizon is a much larger ISP as compared to DQE. So that means traffic from major players like Amazon, Cloudflare, et cetera, got diverted from DQE Communications via Allegheny Technologies, which is their customer, and Verizon. You see the red color choke point here that I've highlighted, creating a massive internet outage. What's interesting to note is that in 2019, December of the same year, NIST, which is National Institutes of Standards and Technology, they usually publish controls and frameworks for avoiding incidents like these. And they published special publication 800-189 that was named as BGP security. BGP is Border Gateway Protocol. It's basically a routing protocol that DQE used in their route optimization. So it's the same year when NIST announced BGP security, and that publication actually had these controls which Verizon could have implemented, which was, for example, using prefix limits. So that what I mean by that is not advertising local routes, just like, for example, blocking a /20 subnetwork, anything below that, smaller networks, not to be advertised to the internet. Now, the questions that interest me in this example are, could we predict the outcomes of network automation? That's number one. And number two is, can we have proactive risk mitigation? So next example is actually an experiment from OpenAI. And they used what is known as RLHF, reinforcement learning with human feedback, which went wrong. So this robotic arm that you see here is trained to grasp this red ball. The red ball appears here as a red dot. But the model learns to hover over the ball instead of grasping it, because one of the human reviewers actually approved this outcome. And so the model learned to what the researchers in this paper call it as AI deception, which is a structural training fault. And so if you go back to case one and case two, when it comes to risk management, the questions that I have is, which of the two do you think is difficult to detect? Is it security misconfiguration, or is it AI deception? Any thoughts? Yep. Absolutely. It's difficult to detect. And also, when you look at the controls that we typically have in cybersecurity, in case of a network outage, we would start with troubleshooting and checking connectivity at every hop. But with the AI system, we would probably go back and check every neural layer for its logical consistency. And that's when we talk about explainability of AI systems. Also, what we need to note here is that detection is a reactive control. So in case of high-risk AI systems, what we really need is proactive risk mitigation. And that's where we talk about auditability and continuous improvement. And my research interests, which I'm exploring with Teagan Maharaj, are in this domain. Also from cyber psychology, what we learn is, because I forgot to tell you that some of the slides are from my previous lecture on cyber psychology at Georgia Tech. So what we learned from cyber psychology is that deception exploits trust. And so, yeah, what was I trying to say here? Yeah, so more research needs to be done on how to detect deception. So I think I've quoted a paper here at the bottom, which uses self-adaptive cyber deception for defense. So something we can learn from cybersecurity. This is another interesting area of research. What you see on the left is, or maybe on your right here, that is the AI chatbot by the name Replica, which was launched in 2017, but Italy banned it in 2023, citing psychological harm for its people. Whereas what you see here in blue is actually an AI therapist. And I've worked with focus group, which in turn works for vulnerable populations. And I know that there is a lot of demand for AI therapist applications like these. But the larger question that interests me is, can we build defenses to prevent cognitive manipulation? And another question is for the systems researchers, can we embed AI ethics with secure app design process? Now, my work with Dr. Courtney Crooks at Georgia Tech was focused on preventing cognitive manipulation. So if you are interested in that work, feel free to reach out. I'll be happy to talk more. And this is one last paper, which I want to highlight from my favorite professor, Don Sang, and she has co-authored it. So this paper by Shi et al. Really talks about how we should have holistic risk management for AI systems, where we not only talk about security, but also safety. And so the goal of safety is to prevent harm, whereas the goal of security is to protect the system. But what's interesting in that paper is what caught my attention is there is always this, sometimes, there can be this trade-off between safety and security goals. Because security is mostly focused on lowercase, worst case, lower bound problems, whereas safety is, baseline safety is focused on having, good performance for average cases. So how do we have this trade-off between average case and edge case performance? And how do we optimize that for risk mitigation? That's something that interests me. And finally, I'm open for research collaborations. If you have more interesting questions like these or would like to talk more, feel free to reach out. That's my email ID. I prefer gothic.edu for now because I'm starting out my PhD this year. And thank you for organizing this. Thank you very much.